We're now live.
All right, we're on the air, and we're ready for quiz for lesson 13.
All right.
Okay, again, first two are given.
Yep. False and false.
Okay, so for 3, what requirements must be checked when conducting a hypothesis test comparing two means with independent samples? Mark all that apply.
Say it again.
Mark all that apply.
Oh, yeah. I thought you said mark all. I was about, what?
No.
Okay, so it's the simple random and then the normally distributed. That's what I would guess.
Now, explain why the it doesn't have to be normally distributed, does it?
Those are two of the 2 points for a. Let me just.
Oh, for the independent. For an independent.
Yeah. So for independent samples, it says data are simple random samples from the population, and point 2, the distribution of the sample means from each group is normal.
Okay.
Cool.
Sample means, yep. All righty. Question 4, the test statistic for the hypothesis test comparing two means with independent samples is a t-score.
Yep.
Score. Yeah.
That's what I would guess.
Two samples are independent if, and I chose the second one for this one. Knowing which subjects will be in group 1 tells you nothing about which subjects will be in group 2.
Yeah, I agree with that.
Yep.
All right, so do you have Brandon, do you have the dentist office bills?
I have it open,
Data
yeah.
open?
Okay,
Okay,
let's
so
paste that into.
I've got mine.
Paste it into the two sample t-test, eh?
Yep. Degrees of freedom. We rounding to 3.
Okay, well, hold on. It wants to make sure that Idaho Falls is U1 and Rexburg office is U2, eh? Make sure you paste it in that way. Okay. And then the alternative.
Significance of 10.
Yeah, and then the alternative hypothesis is less than. And your confidence level is 0.9. Is that right? Everyone got the same? Perfect. Okay. What did you get for degrees of freedom?
37.996.
Yep, that's exactly what I got. Okay, the next one.
You guys are ahead of me. Hold on a second here. Sorry.
Cool.
Let me know if you got your samples in, or your data.
I'm still trying to copy and paste the data in, actually.
Yeah, I took my my spreadsheet, the quantitative inference procedures, and I put a little macro button at the top of each of those 1 sample t-test, pair sample, 2 sample, and a ANOVA. Did a little macro where I could clear.
Oh, that's cool. I just keep closing the whole thing and reopening it again, just in case I made any changes to it like that one day.
Yeah, that could be.
I just went down 1,000. I went down 1,000 rows.
I never
make sure 1,000 each time.
Yeah, I never save it because I'm like Brandon. I'll put something or delete something or change something.
Okay, so we make it less than, right?
Yep.
And level of significance, so we change that to 0.9.
Yep.
Okay, and then the question was degrees of freedom, and that was the 37.996.
That's it.
Very good.
Okay, here I am. Sorry.
Okay, so question 7. What is the sample deviation for Rexburg? I've got Rexburg as variable 1, and I've got, I transcribed that. Oh no, variable 2, sorry. It's 206.637.
Yeah.
Is that what everyone else got?
Yep.
206.637, okay.
I got
206.637.
206.637, right?
Yep.
Yeah, okay, cool.
Then what is the test statistic?
That's got me
Statistic.
going.
Go for it.
Go ahead.
I said I've got minus 0.434.
Cool. Okay. 0.434.
Yep. P-value.
Round it to 3 decimal places.
0.333.
No, yes, you're right, because we have to divide it by 2.
Yep.
Well, it might not be 333, it might be 334, isn't it? Oh, no, 333.
No, mine goes 0.33327, so the 27 is below, so it'd be 0.333.
Yeah. Okay.
And then fail to reject.
So 10 is reject, eh?
It's lower than, or it's bigger than 0.5, 0.05.
Yeah, it's failed to reject.
Yeah, fail to reject.
Oh, flap.
If the
So
if
P
the P is low,
is...
you must fail the null.
Yes. No, don't say fail the null. That makes it sound like it's failed to reject the null. You got to just say
Oh,
reject.
reject the null. So yes, you must reject the null.
Okay.
That's it.
So hold on. Okay, so it's 0.3. Okay, that's fine. Okay, this question 11 I still don't understand.
Okay, let's see.
If you guys explained it, I still don't get which one it is. I was going to guess insufficient data.
Means that the p-value would be twice as much, right?
So yeah, the p-value would be yep.
No, it's like the p-value. What do you mean
Hold
twice
on.
as much? It's like 6 times as much. 6 times 5 would be 30.
Not equal to.
I just changed it to not equal to, and it went to twice as much, 0.666. Or 0.667, if you round it.
Yeah, that's what mine did.
Oh, wait.
Now I want to quickly.
Oh, wait. Which question are you on?
11?
Oh, not equal to. I'm sorry. Not equal to.
Okay, hold on, guys. Did we not get question? I just want to go back to question 9. So is question 9? Yeah, but is the right answer for that not 0.166 or 67? Did we not have to divide it by 2?
We didn't divide it by 2 because we made it. We had made it not less than or greater than instead of not equal to.
No, you lost me. It's a This is a single tab, isn't it?
Mm-hmm.
Yes, it is.
So don't you divide it by 2?
No. If it was not equal to, then we'd be doing both tails, and then we'd have to divide it by 2. But we're only looking at one tail because we made it greater than or less than one of the 2.
Okay.
But we'll find out, huh?
Okay. So the p value
so
doubles. Yep. So suppose instead that you have used the alternative hypothesis, not equal to, what is the, so it'll be exactly the same. I mean, we'd still fail to reject the null hypothesis because.
Right. So we would have insufficient evidence that the mean dentist bills between the 2 cities are different.
So we have insufficient.
The second one.
Yeah.
Okay. No, I'm just trying to work out why. So it's because it's a not equals to.
The p-value is too high for us to accept reject the null.
Well, wait, we failed to reject the null, and the null says that they were equal.
Yeah, but they changed it on this one to not equal to.
Oh, sorry, I'm stuck back on the other one.
So the null says, so this one says not equal to, so we have sufficient evidence that the mean distribution between the 2 cities is different. Okay, so if we had gone with, so Brandon, if we had gone with the first question, the third one would have been right. Oh no, we have. No, the fourth one would have been right.
I'm not sure what you're saying right now.
So I'm saying is if that was just an equals to sign instead of a not equals to, it would have been the fourth one.
No, that's the not equals. That's not the null. That's the alternative. The alternative hypothesis is not equal. The null is still equals.
Yeah.
No, I get it. But what it's saying in this question is suppose that you use the alternative hypothesis. So if we hadn't have used the alternative, we had to use the other one, or not, let's say we had to use this one, but instead of not equals to, it was equals to, we would have used the fourth answer.
You can't have an alternative hypothesis that's equals to because that's
no, I get it. No, I get it.
But he's trying to understand it. Which one would lead to which one?
Okay, I'm getting confused. I'm sorry.
Okay, no, I'll leave it. That's fine. Okay, so we all agree it's the second one, eh?
Yeah, that's what I think it is.
Okay, I think we worked. Yeah, I agree with it. I think I've worked out how these work now.
Okay.
Okay, so now we have to do the data on this one. Delete. This is from Fresh Dinner.
Do we put the students from Utah in the first category or the second category?
And let's see. This data
Let U1 represent the mean number of times a month that a student from Colorado. U1 is from Colorado. U2 is from Utah. So the first one is going to be Colorado. Second one, Utah.
Okay.
Okay. What else do they give you? Okay.
Oops.
That's 0.5.
0.95 and
so then so I would say the first one, hey? Oh no, the second one. For
is the
question
appropriate
12.
alternative. So there's different times. Freshmen from Colorado. You suspect the freshmen from Utah cooked dinner for themselves a different number of times. Different is not equal to.
Yeah, correct.
Yeah.
Okay, cool. So second one.
Yes.
Test statistic is everyone got minus 0.845.
Yeah.
Minus 0.845.
Minus or 0.845?
Negative.
How about negative?
Okay, yeah.
Is the
14,
p-value,
what is the p-value?
is that 0.412?
0.411.
Yeah, 0.411.
Oh, you're right. Yeah. Shoot. 0.411.
Fail to reject.
I never would have figured out that I did that. All right. Fail to reject.
I did that on my homework quiz. I put in the wrong number. I switched my last two numbers on one of my things, and I was like, what? And I looked at it, and I was like, oh my gosh, that was such a simple thing.
All right.
Okay, margin of error. My favorite part.
So we switched the confidence interval to it's already 0.95.
Yep.
2.214. 0.214 minus 5.147 negative equals divided by 2 equals 3.681. Tell me what you guys get.
3.681. Is that what you
That's
got?
what I got.
Yep, that's what I got.
Right on.
Good.
17, of course, would be the negative 5.147.
Yep.
Yep. And 2.214.
2.214.
That was easy enough. Okay. I'm going to go ahead and submit.
You're going to do it? All right.
Submit quiz. %. Good deal. We got it on the first try this time. I think we're getting the hang of this between the three of us. There's always somebody to keep one of us straight.
Right, exactly.
So it's perfect. This is
Because
working out
there's always
great.
going to be somebody that's going to round the wrong way or something.
Yeah, somebody understands one thing better than the other one. So others, this is working out perfect.
Right on. All right, let me turn mine in here.
It's a pity we can't do this on the exam.
Right. Go to submit quiz, submit quiz, submit quiz. And 100%. Right on. Okay, cool.
Good deal.
Time for economics.
Economics. Well, I've just got my new class just popped up. I haven't even started it yet.
Oh, man.
It's a hard